Hi, my name is Evan Vickers, PhD. I'm a postdoc in the lab of David McCormick in the Institute of Neuroscience at the University of Oregon. The brain is a unique object, so it creates awareness and consciousness and allows for living things to respond to their environment and behave. In terms of scientific phenomena to study, I think it's one of the least well understood and probably most complex phenomena that exist. I mean, there's some, you have like astrophysics or cosmology or some aspects of physics that are also like that, but I feel like awareness and consciousness are far more poorly understood than those things. And so that means that if you think about like where we are in the history of neuroscience compared to physics, it's like maybe we're like pre-Einstein, or like it's 1810. Like in neuroscience, it's like we're in the year 1810 and all these really cool new exciting things will be discovered. We study, here in the McCormick lab, we study the brain, and more specifically speaking, we study brain states and fluctuations in arousal and movement that are related to changes in activity across the cortex of the brain. And we're interested in how these state changes in brain activity are related to task performance and how they might predict either, for example, optimal performance or poor performance in a task, or how they might, in general, change how the brain processes information depending on like the arousal state of the individual, like being asleep or awake or excited or bored, for example. For me, it's really been an environment to try to figure out how the brain works, which is cool. I've done research at universities that are affiliated with medical schools, and here being at a big undergraduate / graduate school and in the College of Arts and Sciences, which is a big umbrella that promotes really basic research, there are a lot of differences. When you work at a medical school, there's a lot of pressure that your research be relevant for directly relevant to finding a cure for something or a treatment for a disease. And of course that's still important when you do basic research at an academically focused university, or when you write your grant applications to get funding. But it really, on a day-to-day level, the fact that we don't have to be limited by those short-term goals makes it a good environment to do research. I've noticed that the field of psychedelics is sort of hot right now, and a lot of people are doing experiments, but something that's missing is experiments where people have huge neural recordings, like the kind that we do here, recording from tens of thousands of neurons at once in subjects that are under the influence of psychedelics. This will be, I think, regardless of which papers we publish and which findings we have, hopefully the data sets will also be, we can make them publicly available, and people have already expressed interest in analyzing the data sets themselves. So it's kind of cool to think about a new era of science in neuroscience, which is kind of like maybe an era that physics underwent a while ago, where you have maybe smaller numbers of labs, but some groups that are producing huge amounts of data, and then you have many groups that are all analyzing that data and looking for different patterns. And this might, I can imagine this would create maybe a sense of community of people that are all looking at the same data and playing with it and saying, okay, next time you do the experiment, if you did this a little bit differently, it would then benefit these 15 groups who are all analyzing it. And so maybe there would be more like a back and forth between the groups using the same data, for example. But it's hard to tell what will happen. It's hard to tell, like in neuroscience or any science, what finding will be super important or not as important in the future, retrospectively. I mean, if you look at papers from 20 years ago that have 20,000 citations versus 50 citations, you couldn't necessarily have predicted that in a lot of the cases ahead of time. So it's, yeah, just being able to make new discoveries and see what happens is exciting. So.